Hey Math 20-1 students, I just wanted to go through lesson 3.1b, investigating quadratic functions in Vertex form 2. So what you want to do is make sure that you're doing your homework and practicing these examples to help prepare you for Math 30-1. So we're going to summarize what we want to take from our last lesson. So when we're looking at vertex form, you should always have f of x. This means function notation. And what that just means is if you were to draw a quadratic and you were to take a ruler and go anywhere along it, you should only ever have one x value for every one y value. That's the definition of a function. So that's called the vertical line test. If I take a ruler or a straight line and go anywhere through it, every input has only one output. So that's what that means. Function notation is the same as saying y. It just gives us a little bit more information about it. Okay, so what we want to remember is that the a value is the stretch. Now, when a is positive, okay, so when we see a positive sign or don't see a sign in front of it, that means it's going to be upward facing. When we have a negative sign in front of a, that means it's going to be downward facing. Our p-value is going to be left-right movement. So these are called translations. So if it's going to the left, we're going to see in the equation that there is a positive sign. In the equation, we're going to see a negative sign if it's going to the right. And our Q value is up, down translations. So when it's going up, you're going to see a positive sign. When it's going down, you're going to see a negative sign. So those are kind of the important things that you want to take and use in Math 30-1 eventually. Okay, so in example number 1, we're going to look at this example where here we have a parabola shape. Now, what's important to note is that these parabolas do have arrows on the ends. They do continue downwards forever. Okay, so they're giving us the y-intercept. Now, a y-intercept is a point. So we want to write down the points of a y-intercept would always be 0 and -2. So this is the y-intercept that they're giving us. They're also giving us the vertex, which is 2 and -1. That is labeled as our P and Q. So what they want us to do is they want us to write the equation of this. So it's not really given here, but that's what I'm wanting you to do is write the equation in vertex form. So you would start by writing the y equals a x minus p squared plus q form. And then you're going to substitute your p and q value. So we're going to go y equals a x minus, now we're putting in p as 2, so as you can see the minus stays. The q value we're going to write -1 because it's going downwards. Now, our goal is to solve for the stretch. Now, we can't tell what a stretch is just by looking at the parabola, so we actually need to solve for it. So that's where the other point is going to come in. This is an x and y. That's another point other than your vertex. We can fill it into our y value, so we can say y is -2 and x is 0. And what we're going to do is isolate for a. Move everything over to the left side until a is by itself. So we're going to start by adding 1 to both sides. Okay, so we're going to have -2 plus 1 is -1, which is equal to a times 0 minus 2 is -2 squared, and then we have that's all that's left right now. The next thing we're going to do is we can multiply or we can square that value there. So we can have -1 equals a times 4 because -2 to the power of 2 is 4. So any negative squared becomes +4. And then lastly, we're going to multiply or we're going to divide both sides by 4 because it is multiplying with a. So we're going to get that the a value is -1/4. Now we need to write it out. We need to write that the actual equation for this, the actual function that represents this is y equals -1/4 is replacing your a. Your x stays as it is and y should stay as it is. You should always have your x and y still there once you rewrite the function that represents it. So I should actually label this as a function. Okay, so this is a function, a quadratic function. So remember how our p-value was 2, so we have -2 squared, and then we have -1 for our q value. This is what they're looking for when they say that they want the function or equation that matches the parabola shape. Okay, so you always need to make sure, you can always check by if you graph this, it should look identical to the picture that they gave you going through the y-intercept of -1 and the vertex of 2 and -1. The next thing I want to do is I want to write the equation of the parabola. So they're giving us, again, same situation. They're giving us the vertex, which is our P and Q, and they're also giving us our A value. Okay, so congruency means it has the same shape. So it's going to have the same value. The only thing we have to watch for is they want us to make sure it's downward facing. Now, the only way to do that is to make your A value negative. So we're going to use negative to show that it's downward facing. And we're going to use the same number of A, which is 3. So that's what congruent means, same shape. So we're going to get the same shape by using A equals -3. And then all we have to do is write it in that equation. We already know A is -3. And then we have our vertex, so we would write x minus, we always need that minus, and then we're substituting P as -3 squared plus Q, which is +2. We don't want to leave our symbols like this. 2 negatives should not be left like this. We should write it as a positive. So we want to simplify our answer and say x plus 3 squared plus 2 is the final equation that matches the parabola. So that's the answer I was looking for. So what I want you guys to do is pause the video and try example number 3. Okay, so try this using the help that I gave you for B, example number 1, and example number 2. Okay, so pause the video right now, try it yourself. So now I'm going to give you the answer, so you should have tried it yourself to see if you can do this on your own. First, we want to label what our P and Q are. Okay, so our P and Q. Our P represents the X coordinate of your vertex, and the Q always represents the Y coordinate of your vertex. So in our case, if you look at this point is -2 and 4. So there's our P and Q. So we'll write -2 and 4 as P and Q, label it. Now, in order to make an equation, we always need one other point, which is an X and a Y. So always use another point other than the vertex. So in our case, let's pick this. I could have picked this one. I could have picked this one. So there's lots of different options as long as it's on a definite point. So I'm going to use this guy right here, which is 0 and 2. So that's my X and Y. So we're going to go in and plug that into our vertex form equation. So Y is 2. A we have to solve for. X is 0. P is -2. We have to close that bracket and square outside the bracket. And Q is +4. So when we're solving, we like to move that 4 to the other side. So it's going to become 2 minus 4, which is equal to A, 0 plus 2, because 2 negatives becomes a positive. And so 2 minus 4 is equal to -2. And then we have A multiplied by 2 squared. So go over here. -2 equals A times 4. And then we're going to divide both sides by 4. So A is equal to -1/2. Now, we need to always write the equation. So it's not enough to just say A equals -1/2. We want to write Y equals -1/2. Then it's going to be X plus 2, because we've simplified the 2 negatives to become positive, squared, and then plus 4. This is the equation that they want us to use to represent it. Okay. Now, for this next one, what you're just doing is without graphing, you're just trying to figure out how many x-intercepts there are, meaning how many times does it cross the x-axis. So I'm going to give you an example, and then I want you to pause the video and try the other ones on your own. So the first thing I would do is I would create a little mini graph of this, mini picture of this. Look at what your P and Q are. So in my case, my P and Q are, for the first one, 1 and 8. Okay, so I know that that's going to be in my first quadrant. So I'm going to plot 1, 8 approximately in my first quadrant, quadrant number 1. Now, do you see the negative sign? That means it's going to be downward facing. So if I were to extend this graph going downwards, doesn't matter how skinny or how wide it would be, how many times does it touch the x-axis? You should notice that it touches it twice. It crosses through the x-axis here and here, which means that there are 2 x-intercepts. Okay, so I want you to pause the video and then try the other ones yourself. And once you have them done, I want you to click play and I'll give you the answers. So for the next one, what you want to do is plot the point. The vertex in this case is 2 and positive 1. So 2 and positive 1 would be right there. And we know it's upward facing. So if it's upward facing, it's not going to cross the x-axis at all. So it has 0 x-intercepts. This one, the vertex for the next one would be 2 for P, and there's no Q value. So it's actually 0 if you don't see it. So in this case, this point is going to be right on the x-axis. So 2 and 0 would be right there, and it's upward facing because it is positive 2 for your A value. So because it touches the x-axis because of the 2, 0 value, it's only going to have 1 x-intercept. So whenever the vertex touches the x-axis, there's only 1. This one here, the vertex, there's no P because there's nothing in brackets with it. So that means the P value is 0. And then this is your Q value of -7. So again, we're plotting 0 and -7, which would be about down here. And since this is upwards, it's going to touch the x-axis twice. Here we have the P and Q value. The P value would be -5 because it's 2 negatives to make that positive. And then our Q value is 0 because we don't have one. So that point would be -5 and 0 would be on the x-axis and it's downward facing. Now, since it's touching the x-axis, the vertex it's only going to have 1 x-intercept. Our last one here is 4 and 3. So the negative means that this is our P value and this is our Q value, right? So when we plot that, we have 4 and 3 would be here, and it's upward facing. Let me fix that, upward facing. And that means it's going to have 0 x-intercepts. So you want to be able to, without graphing, determine how many x-intercepts there are. So they want us to write the equation that passes through 1, 15, and 5, and -1 with an axis of symmetry of x equals 4. So the axis of symmetry actually represents your value of P. So we know that P equals 4. What they're actually giving us is they're giving us 2 sets of points, x, y, x, y. Okay, so we can't put them both into the equation, and we're actually missing 2 things. We don't know what the A value is, and we do not know what our Q value is. So last year, whenever there was a time that you had 2 things you didn't know, for example, x and y, or 2 variables you didn't know, you had to do something called elimination or substitution. So this is the process that you're going to see come up very often throughout the course. So if you ever have 2 things that you don't know, you're going to need 2 equations to make it work or to solve those 2 unknowns. Okay, so we're going to start by filling in one of the points into one equation and the other point into another equation, both in vertex form. Okay, so our vertex form, remember, is ax minus p squared plus q. So we're going to start with equation number 1. We're going to write y is 15, which is equal to your a, which we don't know. Our x is 1 for the first equation, minus our p-value, which is 4 squared plus q. Now we're going to simplify this until it looks like a linear function. So we're going to go a, and then 1 minus 4 is going to be negative 3, which we're going to square and then add q. So 15 equals a multiplied by negative 3 squared is 9 plus q. So now our linear equation is, we're just going to put the number in front of our a, so it's going to be 9a plus q. Okay, so that's one linear equation. Now we have to repeat that for point 2. So we're going to put negative 1 equals a, x, which is 5, subtract 4, which is our p squared, plus our q value is unknown, so we write q. We're going to have negative 1 equals a, in brackets 5 minus 4 is equal to 1 squared plus q. So we have negative 1 equals a times 1 plus q, which means that our second equation that we're going to line up, we're going to use, is going to be just negative 1 equals a plus q. So those are our two equations. So our next step, we're going to use the process of elimination. We're going to line them up one under the other, and we're going to do a subtraction. Okay, so I'm going to do that in another color so you guys can see the difference between it. Okay, so we're going to take the two equations. 15 equals 9a plus q. This is called elimination. And we're going to line up the minus 1 equals 1a plus q right underneath. Now, we're going to eliminate the variable of q. And the only way that's possible is by subtracting the top and the bottom. So we're going to have to go 15 subtract negative 1. That's going to be the same as saying 15 plus 1. So two negatives, remember, becomes a positive. So that's going to be 16. You can even put in your calculator if you're not sure. So 15 subtract negative 1 gives me 16. 9a minus 1a gives me 8a. And then q minus q crosses itself off. And our next step would be to divide both sides by 8 to get a equaling 2. So we now know that a is 2. Our next step would be to substitute this a of 2 into one of our equations. It doesn't matter which one, equation 1, equation 2, it will not matter. So we're going to go negative 1 equals 2 plus q. We're going to move that 2 to the other side by subtracting 2, and we should find that q equals negative 3. So those are our two values. Write an equation with an axis of symmetry. We still need to write the equation. So I'm going to switch colors here. And I'm going to write the final equation is y equals, remember our a is 2. X minus p, which is 4. We were given that. And q is minus 3. So this is the equation that would match that description. Our next example, whenever they give us a picture, and you're going to see a few of these in the homework. So whenever they give you a picture, you're going to put this on a Cartesian plane wherever you decide. Sometimes they'll be specific, then they'll tell you where to put it, but in this case, they don't. So we can make this end right at the 0, 0 point. And this end will actually be at the 24 and 0 end because we know that the bottom of the tunnel is 24 feet wide. It even tells us that. We know that the tunnel is 18 feet in height, and in width it is 24 feet. So we can label this point right here as, it's going to be the axis of symmetry, which is 12, so it's half of 24, and the height to get there is 18. So this is our P and Q, and then we can use either this one or this guy to plug into our X and Y. So that will help us solve for our A, because the first question says, what is the quadratic function in vertex form? So we need to write that by going y equals our A value we don't know. So we're going to write 0 because those are easy to substitute. 0 minus p, which is 12 squared, plus q, which is plus 18. We're going to bring this 18 to the other side by subtracting 18. So now we have negative 18 equals a, and then we have negative 12 squared, which becomes positive. Whenever you have a negative squared, it becomes positive 144. We're going to divide both sides by 144.